Hi everyone, what's up? Welcome back to my tutorial channel. Daniel's here and today I'm going to show you how to compute probability using counting principle. So in this video, I'm going to first introduce the fundamental principle of counting. Then I'm going to show you how to find permutation and combination. Let's get started off with the fundamental principle of counting. Here is an example. A certain make of automobile is available in any of three colors, red, blue, or green, and comes with either a large or small engine. In how many ways can a buyer choose a car? So for this situation, I would like to use a tree diagram to illustrate the situation. On the tree diagram, you can see there are three options of colors, red, blue, and green. For each color chosen, there are two options of size, either large or small. So combining the two factors, we can have possibly 6 combinations. Red large, red small, blue large, blue small, green large, and green small. So there are 3 choices of color and 2 choices of engine. The total number of choices is 6. We got 6 combinations, and 6 can be computed by multiplying 3 with 2. So for a system of 2 operations, the fundamental principle of counting says that if an operation can be performed in n ways and a second operation can be performed in n ways, then the total number of ways to perform the sequence of 2 operations is n times n. Now we consider a system of more than 2 operations. Example 1. License plate in a certain state contains 3 letters followed by 3 digits. How many different license plates can be made? So for this example, we have totally 6 operations. The first 3 operations are choosing 3 letters, and the last operation are choosing 3 digits. We have totally 26 letters on the English alphabet. So to choose the first letter, there are 26 possible ways. To choose the second letter, there are also 26 possible ways because replication is allowed in this situation. And it's similar for the last letter. For the last 3 digits, there are 10 ways to choose the first digits, either 0, 1, 2, 3, 4, 5, 6, 7, 9. So there are 10 possible digits for the first position. There are also 10 possible digits for the second position, and also 10 possible digits for the last number. So the total number of license plate is just 26 times 26 times 26 times 10 times 10 times 10. There are totally 17,576,000 license plates can be made. So the fundamental principle of counting for a system of more than 2 operations say that if a sequence of several operations is to be performed, the number of ways to perform the sequence is found by multiplying together the number of ways to perform each of the operation. So that was about fundamental principle of counting. Now I'm going to show you how to find the permutation. Let's consider example 2. 5 runners run a race. One of them will finish first, another will finish second, and so on. In how many different orders can they finish? So this is a system of 5 operations. We are going to find the number of ways to choose the finisher in each operation and then multiply them together using fundamental principle of counting. So for the first operation, there are 5 possible choices to choose the first place finisher. The second operation, once the first place finisher has been determined, there are only 4 remaining choices to choose the second place finisher. And similarly, there are only 3 possible choices for the third operation, 2 choices for the fourth operation, and only 1 choice left for the last operation. So by fundamental principle of counting, the total number of orders of 5 individuals is 5 times 4 times 3 times 2 times 1, and the answer is 120. So we say that there are 120 permutations of 5 individuals. So what is permutation? Here for convenience, whenever we have to multiply a number down to 1, like let's say 5 times 4 times 3 times 2 times 1, we use a notation for convenience that is 5 factorial. So here is the definition of n factorial. For any positive integer n, the number n factorial is pronounced n factorial and is equal to the product of all the integers from n down to 1. So n factorial is n times n minus 1 times n minus 2 down to 1. And we assume that 0 factorial is 1. So the permutation of n objects is n factorial. So that's the definition of the number of permutation of n subjects. Now we consider a situation where we do not choose all of the subjects. Example 3. 10 runners enter a race. The first place finisher will win a gold medal. The second place finisher will win a silver medal. And the third place finisher will win a bronze medal. In how many different ways can the medals be awarded? So in this situation, we have 10 runners, but we are not going to use 10 operations. We are going to choose only 3 runners out of the 10 runners. So in this situation, we have 3 operations. For the third operation, there are 10 possible choices to choose the gold medal winner. The second operation is choosing the silver medal. And once the gold medal winner is determined, there are only 9 remaining choices for the silver medal. And finally, there are 8 choices for the bronze medal. So in this situation of 3 operations, the first operation we have 10 possible choices. The second operation we have 9 choices, and the third operation we have 8 choices. So the total number of ways of medals can be awarded is 10 times 9 times 8, which is 720. So we have the second definition of permutation. A mutation of n items chosen from n items is an ordering of the r items. It is obtained by choosing r items from a group of n items, then choosing another for the r items. So here is the notation for permutation choosing r items from n items. The number of permutation of r items chosen from n items is denoted by npr, or we read n permutate r. So n permutate r is equal to n times n minus 1 times dot dot to n minus 1 plus 1, n minus r plus 1. And it is equal to n factorial over n minus r factorial. So this is the situation when we only choose r items from n items. If we choose n items from n items, the answer is n factorial n, and it is equal to n factorial. The last thing of today is combination. In permutation, when you choose r items from n items, we do care about the ordering of the chosen objects. However, in some cases, when choosing a set of objects from a larger set, we don't care about the ordering of the chosen objects. We only care which objects are chosen. For example, when you choose 3 lifeguards from 5 lifeguards, we may not care which lifeguard occupies which station. We might care only which 3 lifeguards are chosen. So is distinct group of objects that can be selected without regard to order is called a combination. Here let A, B, C, D, and E be the 5 lifeguards. So there are 60 possible permutations of 3 out of 5. And the list of possible permutations can be represented in this table. However, if the order of the letters doesn't matter, then we can treat ABC the same as CAB or ACB or BAC or BCA. So we have only 10 distinct groups of 3 letters. So in this situation, we actually have only 10 ways to choose 3 lifeguards out of 5 if the order doesn't matter. And 10 can be obtained by 60 divided by 6 because we have 60 permutation, and in each column we have 6 permutation can be treated the same. So 10 is 60 divided by 6, and that's equal to 120 divided by 12. 120 is 5 factorial. 3 is 3 factorial, where 3 is the numbered letter in each combination, and 2 is just 5 minus 3. The official definition of combination. The number of combinations of all objects chosen from N is often denoted by the symbol N choose R. The reasoning above can be generalized to derive an expression for NCR. And the number of combinations of all objects chosen from a group of N objects is N choose R, which is equal to N factorial over R factorial times N minus R factorial. Example 4. 30 people attend a certain event, and 5 will be chosen at random to receive prizes. The prizes are all the same. So the order in which the people are chosen does not matter. How many different groups of 5 people can be chosen? Remember, in the problem of 5 runners, we choose the first prize runner, the second prize runner, and the last prize runner. In the permutation situation, the order does matter. But in this problem, 30 people attend a certain event. We choose 5, but these 5 people, the prizes do not have the order. So this is a situation of combination. So since the order of 5 chosen people doesn't matter, we need to compute the number of combinations of 5 chosen from 30. That is 30 choose 5, which is 30 factorial over 5 factorial times 25 factorial, and the answer is 142,506 ways to choose 5 people out of 30 people. So that is everything for today. Now we do some exercises. Exercise 1. 30 people attend a certain event, and 5 will be chosen at random to receive prizes. The prizes are all the same, so the order in which the people are chosen does not matter. Of the 30 people in attendance, 12 are men and 18 are women. What is the probability that all the prize winners are men? So this is a problem of computing probability in which combination permutation are involved. So to find the probability that all the prize winners are men, we first find the number of ways that we can select 5 prize winners from the group of men people. So the number of outcomes in which prize winner is a man is the number of combination of 5 men chosen from 12 men, which is 12 choose 5, and that is 792. So this is the number of outcomes of the event. Now we are going to find the number of outcomes of the sample space. So from the group of 30 people, to choose 5 people without caring about the order, there are 30 choose 5 possible ways. It's just like the combination of 5 chosen from 30. So we got the sample space has 142,506 possible outcomes. So the probability of the event that all prize winners are men is just 972 over 142,506, and the answer is 0.0056. What is the probability that at least one prize winner is a woman? Remember, in the last lesson, I introduced the at least event. Whenever you see a question asking about at least event, think about the complement rules. So the complement event of the event that at least one prize winner is a woman is the event that all prize winners are men. So the probability that at least one prize winner is a woman is 1 minus the probability that all the prize winners are men. So that is 1 minus 0.0056, and the answer is 0.9944. Exercise 2. A box of light bulbs contains a good light bulbs and 2 burnt out light bulbs. 4 bulbs will be selected at random to put into a new lamp. What is the probability that all 4 bulbs are good? So here we have the box contains 10 bulbs, 8 good and 2 bad. So to find the probability that all 4 bulbs are good, first we find the number of outcomes of the event, then we find the number of outcomes of the sample space, and then find the probability. So for the event to have 4 good bulbs from the 8 good bulbs, we need a combination. So there are 8 choose 4 ways to choose 4 good light bulbs out of 8 good light bulbs, and that is 70. So 70 is the number of outcomes of the event. Now we find the number of outcomes of the sample space. So to choose 4 bulbs out of 10 bulbs, there are 10 choose 4, which is 210 ways to select 4 bulbs out of 10 bulbs. So 70 is the number of outcomes in the outcomes of the event, and 210 is the number of outcome of the sample space. So the probability that all 4 bulbs are good is 70 over 210, which is 1/3. So that is everything for today. Thank you so much for watching my video. I hope you guys find my video helpful, and bye, see you next time.